Hi, welcome everyone to today's webinar. Firstly, I would like to give a quick introduction to myself. My name is Malaka. I'm a senior tech lead at WSO2. During my stay, most of my work was focused on ESP development and SOA integration products and extensions. Currently, I'm working with a team that develop extensions on top of WSO2 products, mainly ESB and identity server. So this includes ESB connectors, IS authenticators, and provisioning connectors so far. So we have several extensions for VPS and CEP in a long-term plan. So today I intend to give you some concepts of extending ESP Enterprise Service Bus and what are the extensions already available from WSO2 store, which was recently released after the ESP 490 release, which is the latest version of the ESP, and also discuss some of the challenges when integrating enterprise applications, how WSO2 products and extensions help to solve those. Then we look at how community can contribute to the WSO2 extension to the store. So this is the first webinar in this series. So this is a new area that we have released recently. It was there for 4.0. It was connectors were there from 4.0. But at that time, we only had 5 connectors, and with the 490, we had a major store release, which has like more than 100 connectors. So during today's webinar, I will give you a brief introduction to connectors and the connector framework. So in the upcoming webinars are going to be interesting. So we'll be having those on 10th and 15th of December. And we'll be focusing on giving you real use cases with demo sessions and how we can really build this type of use cases using WSO2 ESP, Developer Studio, and connector framework connectors. Okay, so let's start our discussion with general facts of what and how software is used in modern enterprises. Today, most organizations heavily rely on software applications. So it's all used by different employees at different levels. So it is fair to say that software drives the modern day businesses. So why the software is being used by organizations today? So it is mainly to save time and to increase productivity, and also to automate complex processes and repetitive actions, and also to real-time monitor and alert detection and problem detection. However, we see that most of these solutions does not even come closer to the real goal. Some of the solutions will run over the budget, and some introduce additional overhead and problems. So why is it failing? So is it something wrong with the software? So maybe we are not using the software right way. So in any of the organizations, all business compose of several departments or several teams. For example, let's take the scenario of manufacturing a car. So it's done with the help of many departments or teams. So one team builds the engine while the other builds the chassis and other body parts. So finally, all these components need to be integrated to have the final product. So what is the solution we can provide for such an organization? So we need to integrate all these systems so that it can communicate and exchange messages. So this requirement leads us to the enterprise integration. So this is a very broad area, and a lot of research and development is still happening even today. So this is one of the difficult problems, since there are a lot of different systems running on different platforms. One system may be running on cloud and the other system is running on premises. So we are talking about hybrid integrations there, and many protocols and legacy standards. So this makes the integration more challenging and difficult. Okay. So when integration systems, maybe at the initial stage, when you're starting a software project, there may be only few integration points or integration systems that we need to integrate. But over the time, this may increase, and if you don't plan for this at the initial stage, what happens is you may end up with a similar structure where it's nightmare to scale and troubleshoot, maintain. So this type of architecture will end up in a spaghetti type of integration where it's very hard to maintain and scale and troubleshoot when there's an issue. So due to that, the whole system can fail. So what is the solution? So if the ESB is the solution, so actually the definition for ESB is, so if ESB is a software architecture construct which provides fundamental service for complex architecture. So that's the definition of the ESB. So ESB does not solve the problem, but it provides services, tools that can be extended, mixed, and meshed to solve the integration problems and challenges. So basically, this represents the data bus used in computers and provides the uniform approach for integrating systems. So also this reduces coupling by eliminating point-to-point connection links. So as I mentioned earlier, the ESB does not solve the problem, but it provides services and tools that can be extended and mixed and matched. So when selecting an ESB for enterprise integration use cases, it is important to validate how easy it is to extend and availability of the extension points in the ESB that you select for your integration use case. Okay, so why WSO2 ESB? So those of you who have already worked on WSO2 may know that it's a very lightweight ESB. So the binary distribution itself is around 250 MB, and there's no advanced installation or IDE required, only just Java, and you need to set the Java home and JDK. That's all you need on your platform. So using WSO2, users can build the integration scenario out of the box. So it's a high performance server with low resource utilization and takes very low memory footprint. So it supports comprehensive REST, SOAP, and WS Star support. And it also provides connectors to support integration requirements that is available freely. So it's open source. The connectors are also open source, that you can download it free. And no code, only configure driven. Same applies to using connectors and streaming connectors. Just need to add, configure, and run, and provide listening, sending extension points to easily extend the ESB product. Okay, so this diagram shows the high-level architecture of WSO2 ESB. So I'm not going to talk about each of these components. I'll be focusing on connectors and inbound endpoints during this session. So from previous versions, the proxies, APIs, and main sequences were included. With the latest release, that is ESB 4.90, there were new message triggering points called inbound endpoints. So we will discuss more on this during the later part of this discussion. So we have an idea about inbound endpoint. So next is a connector. So inbound endpoint is basically a message triggering point. So the next thing is the connector. So users who have already used WSO2 ESB may know that mediator is the basic element that can be used in a mediation flow. So mediator is a basic unit. If you take mediator as a black box, you send a message, and based on a configuration, it transforms that message. So that's the basic idea of a mediator. But having said that, all mediators are not used to transform. There are some mediators which can be used to send out a message or like that. So in summary, so mediator is a basic unit of it's a basic configuration unit, and sequence is a collection of mediators. So connector can be used as a mediator in ESP, WSO2 ESP. So users just needs to add this connector with required parameters, and connector will do the required action. Most likely it will be calling a third party or cloud API. So this provides the abstraction layer to the API. Users who integrate does not need to know about the API implementation or does not have to go to each documentation about the API, and only concentrate on the integration scenario. Okay, so if we consider previous versions of ESP, writing a custom transport can be done at access to layer. So this comes in listeners and senders. Even this can be done with this way, but it's not. It has some limitations. So for starting, so it's not dynamic. So every time you add something, server needs to be restarted, and it does not support the multi-tenancy fully. Fully multi-tenancy storage. So when it comes to the latest release, custom inbound endpoints gives the feature to add custom message triggering points to ESP, and connectors can be used to write custom senders. So this is fully dynamic, meaning it does not require to restart the server and support multi-tenancy. This is fully compatible with Carbon application. So if you are familiar with the Developer Studio, so during the next couple of webinars, we are going to give you a demo of how this can be done with how you can manage your mediation flow with Developer Studio. That's our tooling that we recommend to use with WSO2 ESP, and so it's fully compatible with Dev Studio, and users can just include connectors and relevant configuration in one single application and upload it to the ESP. So it's ready to use. Okay. So EIP pattern. So enterprise application integration is a key connecting business is to connecting business applications with different systems. Over the years, architects of integration solutions have invented their own blend of patterns in variety of ways. But most of the architects have similarities, initiating a wide accepted standards and architecturing integration patterns. Most standards describing integration patterns. So channel adapter is one of the patterns. So with connectors, WSO2 is channel adaptation pattern. So use a channel adapter that can access the API or data, publish messages on channel based on data, and can receive messages and invoke functionalities inside the application. The adapter acts as a message client to the messaging system and invokes the functions by the application supplied interface or API. So this way, any application can connect to the messaging system, be integrated with other applications as long as it is the channel adapter. So we'll be covering the EIP, the channel adapter with the connector. Okay, so how to use a connector? Okay, so Connector store is independent of the ESP releases, so it is hosted in a different URL. So I will show you the URL in a few in next couple of slides. So users can directly download the connector from WSO to connector store. So this is basically a zip file. So once zip file is downloaded, so we just need to upload that connector and enable it. Then we are ready to use the connector in your mediation flow. So the same can be done with Developer Studio latest version, that is 3.8. You can just import connector directly from the tool itself. So you don't need to go to the store manually and download the zip file. So you can browse the connectors within the tool itself. So that functionality is there, built into the tool itself. So can be configured and added to the same Carbon application and upload it to the ESB server. So in this diagram, I have shown you the two different approaches. The first diagram on your left-hand side is the one that is using the Developer Studio, and the pop-up is where you can browse for connectors. And the other one is you can just manually download the connector and just upload using this connectors menu. You find it on your left-hand side. So just need to upload it and enable the connector. Okay, so using the connector in your configuration is straightforward. So just need to check the connector operation documentation and add your relevant method in your mediation flow. So let's take the example where user needs to, I think most of you are familiar with Salesforce. It's a CRM application. So I will give the example in Salesforce. So let's take where user needs to query Salesforce objects to get account details. So without connector, let's say if we want to cover this use case without connector, then user has to check the WSDL of the Salesforce API and format the request as expected, and finally get the endpoint and call the endpoint. So that's the process we need to follow. But when you're using this connector, same can be done. So using the given configuration in ESB mediation flow. So you just need to have the Salesforce query method called and pass the relevant method. That's it. So no need to worry about what's the WSDL, and all these things were taken care by the connector itself. Okay, and the connector store is live and can be accessed from the URL given there, www.store.wso2.com. So it's freely available for public, so you can just try it for free. Current store has connectors and streaming connectors. So we only have a limited number of streaming connectors, but there's going to be some more streaming connectors on the pipeline, which will be available in coming months. So using WSO2 ESP and streaming connectors, users can listen to outside events and trigger custom actions based on events. For example, whenever there's a tweet falling into some criteria, you can send a SMS or mail using Twilio or Gmail. That's a use case which can be easily handled with Twitter inbound and Twilio and Gmail connectors. So if you are planning to write your own connector or contribute to WSO2 connector store, follow the links provided in this slide. So this includes details of how to write a connector and required Maven archetypes and connector framework for writing connectors for SOAP or REST-based APIs. If the vendor is supporting Java SDK, so we can write on Java code and use it in your mediation flow, and maybe wrap the Java code as a connector and provide the functionality to ESP. So all these things are possible. So before writing a connector, the first thing the user should do is analyze the API, what type of support they provide, and based on that, select the best way of implementing the connector with WSO2 connector framework. And also, if anyone is interested in contributing, there's a guide for what are the things you need to provide to contribute to the connector store. So you can send us a pull request, so we will validate and add your connector to the store. Okay. New feature, inbound endpoint. So inbound endpoint is a feature introduced with latest version of WSO2 ESP. Inbound provides the advantages mentioned in the following slide. In summary, inbound endpoint is a message source or triggering point for ESP. So ESP out of the box, ESP comes with default set of inbound. So also we can write a custom inbound to listen to outside events. So using this framework, there is a streaming. So using this framework, there are a lot of streaming connectors that are built. So these will be available in the store as well. So currently we only have the Twitter streaming connector, and soon we are going to add the Salesforce streaming connector. So you can listen for Salesforce object update, and also with the Twitter you can check for Twitter streams. Okay, so when you are writing inbound, there are 3 types of inbound endpoints that is supported by ESP. So the first type is listening inbound endpoint. The second one is polling inbound. So you just use while loop to just poll some endpoint and see if there are any messages or something like similar to AMS transport. And also event-based inbound. So you register something, and based on event, you invoke the mediation flow. So those are the 3 types of inbound endpoints we have. So when you run custom inbound, so streaming connector, it can go into any of those. However, for streaming connectors, we are widely using either polling or event-based inbound endpoint type. Okay, the streaming connectors are written on top of custom inbound endpoints provided with ESP 490. So using these features, you can configure a triggering point in ESP to an event. So whenever there's a new tweet, as I mentioned, so ESP, you can invoke an ESP sequence. Similarly, for Salesforce, you can do the same. Okay, polling inbound coordination. Okay. So when streaming from third-party cloud APIs, the following can be configured to increase either performance or fault tolerance. So this feature is inherited from the inbound endpoint framework. With this, users can configure to stream from. So the recommended approach the recommended deployment we recommend is the manager worker architecture. So in that case, what we do is we have one manager node where users can access the UI and configure your cluster, your ESB, and this is only used for configuration, updation, and managing configuration. So this will not be used as a worker. And the worker nodes are just high performance servers. It does not load the UI component, but it takes the configuration for the manager node and runs the configuration. So users can have many workers as they like based on your workload. So in that case, that's our recommended deployment architecture, worker manager setup. So with this, users can configure to stream from all workers or single worker in a ESP cluster. So when configured to use a single node, that means you say clustering coordination true, it makes sure it will only listen from one worker node at a given time. If that listening worker node goes down for some reason, it will start to listen from another worker. So this is what I meant by faulty tolerance. So it makes sure only at least one worker is listening to your external event. And if you want to increase performance, if you want to get these messages from multiple workers, then you can make this coordination false. So except manager, every worker will listen to your external event. So that's the functionality that is inherited from the inbound architecture to the streaming connectors framework, streaming connectors. Sorry. Okay, so when comparing WSO2 ESP with other similar products, WSO2 still remains on top when it comes to performance and stability. So there's a separate article on that, and also it's mentioned in the ESP release webinar as well. If you are interested, you can take a look at those articles or webinars. Same behavior will go into the connectors since it's running on top of WSO2 ESP. Okay, so this brings us to the end of today's webinar. So in summary, today's webinar is mainly focused on giving an introduction about inbound endpoints and connectors and streaming connectors. So the next couple of webinars are going to be more on demo sessions on how we can build these use cases and some examples of real use cases that we have implemented using connectors and streaming inbound. So I invite all of you to join this, join the other webinars as well. Meanwhile, if you have any questions, feel free to send your questions now. Okay, so we have a couple of questions, so we will take the question. So there's a question. So what the question is, what is the difference between listening inbound listener and event listener? Okay, so usually the difference is so we have three types of listening, polling, and event-based listening. So listening is that you give some port, and it's similar to the HTTP protocol. So you give a port and you listen on that port. Server will listen on that port for incoming requests. So that's listening. So server is not pushing anything from outside event. So clients will send the request to the server server and port. That's listening. And event-based listening is something that from the server side, we register for an event and waiting for a when this event happens, they send us a push request from their side. So that's so we will be notified whenever there's a event occurs on the site. So that's the main difference. And polling is we periodically check for statuses. So those are the three types. And we have another question: do we have tutorials for learning so that we can choose this for our customers? Yes. So far we have a lot of articles. So we have a lot of articles about how to integrate with different systems, and also there's going to be in the next couple of sessions we'll be doing the real use cases, 2 from each session, so you can straight away get the idea of how to apply these connectors in a real integration use case. So those will be taken as tutorials in the next upcoming webinar. And also in the ESP connector documentation, there's and also ESP documentation provide information of how to use a connector and what are the things you need to do. The steps I have already mentioned steps, and also which will be devoted during the next upcoming webinars as well. Okay, so there's another question: why is the JMS connector polling only? So actually the JMS support. So what we have like different inbound endpoints out of the box from WSO to ESP49. So one is JMS. So the behavior of JMS is that's the protocol behavior. We are using polling for that. So we have like specific protocols like MQTT. And for Kafka, so those things are like event-based listening. So that depends on the implementation of the protocol. So that's basically about it. So there's another question: will the inbound JMS endpoint support transactional messaging for ESP? So yeah. So I think we support transaction messaging. So it's all in the documentation. So if everything works fine, only it will remove the message from the queue. Otherwise, it will still retain on the queue and it will be retried. So we have a couple of more minutes. Maybe if you still have any questions, feel free to send the questions across. Okay, so we have another question on JMS. So how to load balance? How load balancer work with ESP? It's regarding JMS. So I think what the question I understood is how we can increase the performance of JMS processing. So in that case, there are several ways you can do it. One way is like you can so if you want to increase performance, then you can increase the number of worker nodes that listens to your JMS, so that more than one node can process and do the mediation flow for your JMS message. So that's one way. But if you're concerned that it should if you're concerned about your fault tolerance, then you can adjust the coordination behavior to true, that it will only one worker will listen to the message. But if one worker is listening to the message, then there's going to be a performance overhead, because it will be processed only one after other. So if you want to process messages parallelly, then we can horizontally scale the worker nodes. We can add more worker nodes as required. So that's all the questions we have for today's session. So thank you for joining, and hope to see you all on for the next couple of webinars. So it's going to be pretty interesting because we are going to do some live demos. So hope to see you all. Thank you very much.